Okay, 6.11, integration by parts. Integration by parts is typically used for the integration of the product of two functions. So for example, the integral of f of x times g prime of x is equal to f of x times g of x minus the integral of f prime of x times g of x. Okay, you may also see this as the integral of u times v prime is equal to u times v minus the integral of u prime times v. In this course, I'm not going to use too much the u and v because it can get confusing, especially if you're writing pretty fast, to be able to tell the difference between your u's and your v's. Integration by parts is based on the product rule. So for this, I'm going to do the proof of the product rule. So it says f times g prime is equal to f prime times g plus f times g prime. So for our integration, we want to get this in terms of f prime and g. So I need to get f prime and g by itself after I take the integral of everything. So for example, if I was to integrate each part, I would have f times g, because the integral and the derivative cancel, is equal to the integral of f prime g plus the integral of f g prime. Okay. Then I want to get fg prime by itself, so fg prime, so I would subtract the first integral over, so I have fg minus the integral of fg prime is equal to the integral of fg prime. And then notice if I was to put that integration in the front, okay, and have this in the correct order, I would actually get my definition for integration by parts. So just a very short proof. Okay, basic rule for choosing f and g prime. So for f, choose something that becomes simpler when you take the derivative. So it becomes simpler. And for g prime, choose something that can be easily integrated. So if we look at our example here, our f, which is something that would become simpler after we take the derivative, would be x. And our g prime, with something that's easy to integrate, would be the sine of x dx. Okay, so for f, I said this is x. When I take the derivative, this is 1 dx. G prime is going to be sine of x dx. And if I integrate this, I get negative cosine of x. So if I use my formula, the integral of fg prime is equal to f times g minus the integral of f prime g. I get that f is x and g is negative cosine of x minus the integral of f prime, so that's 1 dx, times g, which is negative cosine of x. Okay, so I simplify this and I have negative x cosine of x plus the integral of cosine of x dx. And so I simplify this because I can easily take the integral of cosine of x. Okay, the integral of cosine of x is sine of x, so this is going to be plus sine of x plus c. That's my answer. Okay, if this part of the integral was not as easy to integrate, so it was a little bit more complicated, then you would do integration by parts again. So do integration by parts until you have something to easily integrate. Okay. However, let's say you approach a problem, you're trying to do integration by parts using the basic rule, and you notice that no matter what you do, you're going to end up doing integration by parts over and over and over and over again. Well, there is something to help simplify that, and that is tabular integration. So it says differentiate to 0 for the chosen f of x, and then integrate your chosen g prime of x the same number of times. Follow the sign convention, which is plus minus repeating. So important information here. We are going to take the derivative until we reach 0. Okay, so notice that is my f, so x to the 4th. Because if I continue to take the derivative of x to the 4th, I'll eventually get 0, versus if I was to take the derivative of sine x, it would just go back and forth between sine and cosine. So then it says integrate the chosen g of x the same number of times, so that's sine of x dx, and we are using a plus minus repeating pattern. Okay, so my f of x is x to the 4th, and again, I'm going to take the derivative until I get to 0. So that's 4x cubed, 12x squared, 24x, 24, and then 0. Okay, my g prime of x is sine of x dx. So I integrate one time and I get negative cosine of x. Integrate again, I get negative sine of x. Keep integrating. And then eventually I'm going to end on negative cosine of x. And I should have the same number of derivatives as I do integration. Okay? Then I'm going to match up my first function f to my first integral. Okay, and I'm just going to keep doing that until they are each matched up. Okay, and then it says I'm following a plus minus pattern, so this should be plus minus plus minus plus. And then notice I didn't have to integrate one more time, because when I multiply 0 by that next part that I was going to integrate, okay, it's just going to get 0. Okay, so it's not going to really matter there. Okay, so from here I have my answer. I just put everything together. Okay, so I have x to the 4th times negative cosine of x plus 4x cubed times negative sine of x minus 12x squared times cosine of x plus 24x times sine of x minus 24 times negative cosine of x plus c. So notice my signs plus, minus, plus, minus, plus, okay, is following that plus minus repeating sign. And if I was to simplify this, I would get negative x to the 4th cosine of x minus 4x cubed sine of x minus 12x squared cosine of x plus 24x sine of x plus 24 cosine of x plus c. So this entire thing would be my answer using that tabular integration.